All right, so there's stuff you should be doing. If you go to samsclass.info and 141 here, you'll find a schedule of things to be done. Let me get this out of the way. All right, so this is just the intro, just to get people started. And so next week, I'll cover the first chapter in the book, encryption, and you should do a quiz before class. You have to read the book and do a quiz before class. It's online in Canvas. And the first discussion is due. You'll see information about that inside the Canvas. So you should do those things. Do the quiz before class. You can do the discussion after class, but you should do it that day. By the way, these things are not, you aren't going to be punished for being late on the first few things until after the add date. That's what these asterisks are about. But if you want to be caught up, you should do that. And I'll talk about the normal encryption there. And then projects will appear. You should get started on the projects. And the first one is C101, which is binary games. The only thing, much in the way of actual math in this class. We're not going to do the fundamental math behind these cryptographic techniques in any great detail. We're just learning how to use them. The projects are linked at the top of the class page, and they're here. And C101 is here. And that's binary games. So what I recommend is do just one of these a day. If you do too many of them at once, you can get befuddled by them. But the point, I'm trying to imitate the Khan Academy, where you have to get 10 in a row right of the first thing before you do the next thing. Because the fundamental problem with binary is people try to do too much too fast. Just do one step and get it. And then wait till another day and do the next step, and then it works. So let's talk about nibbles. So normal numbers we're all used to, 147. 1 means the number of hundreds, 4 means the number of tens, and 7 means the number of ones. So you could say 1 times 10 squared, and 4 times 10 to the 1, and 7 times 10 to the 0. That's what we're doing with normal numbers. So you have hundreds, tens, and ones. Now in binary, you only have 0 and 1, nothing else. So 1, 1 means 1 times 2 plus 1 times 1 for 3. There's 1 times 2 to the 1 plus 1 times 2 to the 0. So you got 1s, 2s, and 4s in a 3-digit number in binary. So this number is 5, a 4, no 2s, and 1, 1. And so you can count to 7 with 3 bits. This is 1, 0 is 2, 1, 1 is 3, 100 is 4, and 1, 1, 1 is 7. It's 4 plus 2 plus 1. And if you have 4 bits, you have what's known as a nibble, half of a byte. You have 1s, 2s, 4s, and 8s. So this number is 9. You have 8 and 1 and nothing else. So if I can get down to there. So here's how you count to 15. You go up to 7, you add 1 more, you get this. This is 8. 10, 10 is 10 because it's 8 and 2, and all ones is 15. So that's it. Those are the 16 nibbles. That's all you can get with 4 bits is 16 values. And to play the game, you go here and it asks you a question. Convert that number to decimal. That's 9. It's 8. No 4s, no 2s. That's 9. And that's 1. And that's 2. And when you get 10 correct, you'll get a flag here. And you can just turn in a screenshot of that with the flag. To claim your points, you can submit it in Canvas at this project, C101. And that's the way most people will do it. And you'll find there's a bunch of these. They're worth 5 points each. And you cover various topics, nibbles, then bytes, hexadecimal, modular arithmetic, XOR, and so on. So do a few of those. It'd be a good thing for you to do. And of course, feel free to move ahead. There's no reason to wait until projects are due. You can move ahead to other ones if you like. There's a lot of extra credit. And this thing called CryptoHack is an online cryptography program system that is wonderful. If you do that, that's worth extra credit too. And all these things. Anyway, I'll talk about them and demonstrate them as we move ahead. But I think that's it for tonight. That should get you started. I'm going to stop that recording.